Hi everybody. Today we're going to cover some of the basic concepts of remote sensing, and I think what's really interesting about this field is that it's constantly changing. And so what remote sensing entails today is different than what remote sensing was 50 years ago, and is different from what remote sensing will be probably 10 years from now. We're constantly evolving and improving our applications. But it's not as though our old techniques are just thrown away when there are advances in the technology or in methodologies. We're actually always building on what we've done in the past and improving it. So we're going to cover just a little bit of some of those basic concepts and ideas, and talk about how that's changing moving forward. Even as recently as, say, 10 or 15 years ago, most universities didn't have courses in remote sensing, but they may have had courses in photo interpretation. And that's because for decades, that's what remote sensing was. It was essentially using the human eye to identify objects in photographs, or to examine conditions in photographs. And there's an entire science built up around that, about being able to discriminate objects in a photograph, and this is called photo interpretation. Photographs are the medium for photo interpretation, and it's important to make a distinction that when we're talking about the remote sensing that we'll be doing in class, we are not looking at photographs or pictures, we are looking at imagery. A photograph defines something very particular, which is some sort of a paper medium that uses a chemical reaction to detect differences or variations in the energy that hits that film. And this was really how remote sensing all got started. I'll show you a quick video about that. The science of photo interpretation really got its start back in World War II, and this was much more complex than just looking at photographs to identify objects. What the analyst was trained to do is actually take two separate photographs of the same location, line them up just right, and then look at them through what's called a stereoscope. This stereoscope is really a lot like 3D glasses you would get in the movie theater, and essentially when looking through this stereoscope at this set of photographs, the analyst could see the surface in 3D. And essentially what they would do is they were trained to use what we call elements of photo interpretation. So this was really cutting edge science back in the day. And they would try to use some very specific techniques to identify the objects that they were looking for. So let's go through what some of those techniques are. As we go over these various elements of interpretation, it may seem trivial, but really we have to pay attention to what our brain is doing automatically. When we're doing this with our eyes, we don't have to think very hard about specifically what characteristic it is that's helping us identify objects. But when we try to transfer these techniques to a digital platform, we really do have to be able to articulate what it is exactly that our brains are doing. So one of these elements is just simply size. So often you may have objects in your imagery, that look quite similar. We have these long rectangles. Some of them are dark. This one is a dark rectangle, which is really, if you think about how a computer would see this, very similar to this dark rectangle. And these light rectangles to a computer may look very similar to this light rectangle. But we can tell, and we know intuitively, that something approximately 15 feet long is probably not a train or a tractor-trailer rig. And so we can train computers to be looking for objects of specific size. But when we're looking at this in photographs, we always have to be very careful to consider the scale of our photograph as well. Shape is another common characteristic that's used to distinguish objects from each other. And this might be another one of those characteristics that you tend to think, well, duh, of course I'm going to be looking at the shape of objects. But this can actually be a lot more complicated when you think. Particularly, consider that when photo interpretation was applied to forestry applications, really shape was the primary characteristic that they used to distinguish different species. Trees grow in different ways. Their canopies have different typical structures, and the analyst would be trained. And if you think about taking a class in photo interpretation, you would have to be able to look at this, for example, and be able to tell that this was a red pine versus this was a white pine, just because of the way that they typically grow and how that looks from an aerial platform. So shape really can be much more subtle than you might think. It's not always just distinguishing a square building from a round tree. Analysts were also trained to be able to use shadows to identify the height of various objects off the ground. So if they had information for their photographs as to the date and the time of day the imagery was acquired, they could actually calculate the distance or the length of these shadows and use that to calculate height. The texture, or if you think of it as sort of the pattern or variability in the intensity of light reflected in an image, this texture is also really useful in distinguishing different objects, particularly when they're similar materials. So for example, here we have an avocado field, which is vegetation, but we also have a lawn, which is vegetation, and over here we have some pine, more vegetation, and a wetland, which is vegetation. So if we were just looking based on color, because we think vegetation is green, these may look very similar. But if we can actually start pulling out information about the texture of the light that's reflected back at the sensor, that can give us a lot more information to help us identify different objects. And this is another characteristic that, thanks to modern advances in digital image processing, we can actually train computers to look for. And essentially what we do is we identify sort of like objects. So the computer would say this is all very similar to each other or to itself, but different from this lawn, and it can look at the variability within that object, and that gives us an idea of how much contrast there is within all of the different pixels. Pattern is another characteristic that we can use to identify objects. Typically, natural materials have very random patterns, very smooth edges, whereas human-made materials or human structures tend to be much more sequential in their patterns, much more geometric in their shapes, have more defined boundaries. Even again, when we're talking about vegetation, people tend to have patterns and make patterns of everything that they create. So sometimes that can help distinguish one feature from another as well. When we talk about tone in photo interpretation, it's really referring to how much variability there is between your lightest and your darkest pixels in an image. You know, how much range there is in the intensity of reflectance signal that the detector is receiving. And this really can vary by wavelength. So for example, some of the shorter wavelengths, like the blues and the greens, they tend to scatter more, and so you tend to get more of a hazy image in those shorter wavelengths, whereas if you look at some of the longer wavelengths, the exact same image, you can see that the brights are a little bit brighter and the darks are a little bit darker. So this difference is what we call contrast. When you have two neighboring areas and there's a really large difference between them, so their boundary is pretty distinct, we think of that as having high contrast. And again, we've adapted this to digital image processing. You actually can enhance your imagery. So even if you were looking at these shorter wavelengths, there are techniques that you can enhance your imagery to be able to increase this contrast. So far, all of the elements of interpretation that we've been talking about could be applied really to just one band of imagery, so one set of wavelengths that are being amassed into a grayscale image or a black and white image. But color is really especially useful to us because color allows us to incorporate information not just from one band or one set of wavelengths, but also from others at the same time and look at them simultaneously. And this suddenly gives us a lot more information about the features that we're looking at on the ground, because we know that different features interact with light at different wavelengths in different ways. So if we can look at more than one wavelength, in one region of the spectrum, materials may look very similar, but in a different region, it's possible that they look very different. So by adding in multiple bands to look at, we're able to distinguish much more than we could have with just one grayscale image. Let's practice a little bit. What you're looking at here is a 1995 grayscale image of the UVM campus. This should look a little bit familiar to you. Here is the clover leaf coming off of I-89. You can come up Route 2 and see the funky intersection for Spear Street. Here's the Patrick Gym and Aiken. Here we are, right over here. So one of the other things that's really useful, if you have any personal knowledge of the area you're looking at, is just geographic location and context. So you might know what a lot of this is just because you're familiar with this region. But consider those photo interpreters, those analysts back in World War II who were looking at images from another country in a place they'd never been, or even more familiar with, common practices for building, or what the roads were like, or what the vegetation was like. So they had to use all of these photo interpretation skills, all of these different elements of interpretation. And sometimes just one element is useful, but actually it's usually a combination of those different elements that would help them identify the features they were looking for. So let me just give you an example here. If we didn't know anything about this area and we just see a rectangle here, it's sort of a mid-gray rectangle, and there's some little white, there's a little bit of texture in there, and we compare that to this gray rectangle over here, really in terms of their color or their spectral intensity, they're similar. In terms of their tone, they're similar. There might be slight differences in the texture, but not anything really drastic. So we have to use some additional pieces of information to try to figure out what these two images are. And we can just use context. So for example, it's pretty obvious that this is a parking lot with even some little cars around it. So that tells me that this is likely a building, especially since it's attached to other rectangular features which are taking on a very man-made characteristic. On the other hand, if I look at this one, I do see some shadow here, so it looks like it's got some height, but it's surrounded by lawn, so I really doubt that this is any kind of a man-made structure. But considering the texture that I see within there, it does look sort of similar to the textures that I'm seeing over here, a little bit more smooth, which makes me think that this is likely vegetation, but a little bit different than the natural forest over here. This is likely some sort of a man-made plantation. So you can see how we've used sort of the context and the geographic location to be able to distinguish those two features. How about another one? Let's try another one here. In this area, right in here, again, if we were going just based on tone or color, it looks pretty similar, this parking lot. Perhaps they're expanding this parking lot here at the, I think that's the Hilton. Maybe it's overflow parking. It's hard to tell, but again, the texture is similar. The one thing that is different is the shape. So this sort of has a very obvious shape with a crisp border, whereas this one looks a little bit more, I don't know, rough, a little more natural. But it's hard to say without having a little bit more information, because really these two surface materials look similar. Maybe if we look at this with color imagery, so we split up this, what is really one panchromatic band. So what this photograph has done is it's taken all of the energy reflected across the entire visible wavelength, so all of the blues, the greens, and the reds, and it's just smooshed them all together and averaged them, and what we're seeing is the intensity of all of those wavelengths. But if we can break this panchromatic band down into its individual bands so that we can see it in color, we might have a little more luck in being able to identify whether these really are the same type of material. This is much better. So now when we're able to use all three of those bands and look at a true color photograph, just like what our eyes would see, there's a very obvious difference between this surface and this surface over here. So it does appear that even though when you combined all of those wavelengths, the red, the greens, and the blues, that these look similar. In fact, it's mostly the green wavelengths that are contributing to that intensity for this region here. There's one more feature that I'd like for you to look at, and that is this funky little circle with a square right here. So we've already talked about how when you start seeing these very obvious sort of geometric shapes with these very crisp edges, that they're likely something man-made. But looking at this, if we weren't familiar with this area, it might be very difficult for us to figure out what this is. I can try to take some clues. It's surrounded by what looks like lawn, but it has a road leading up to it. It appears to have one type of material in the center, the circle, and it's outlined by a different type of material in the square around the edge. Maybe it's a building with a cooling unit on top, but there's one other characteristic that we can consider that could help us determine whether that's the case, and that is, hopefully you can guess this, it's the shadow. So when we look at, let's go back. It's a little bit easier in the panchromatic image because it was taken earlier in the day, so that there's a little bit more shadow in this one. So take a look at the shadows along the edge of this building here. You can see them also along the edge of this building here. So the higher the object, the larger or the more obvious the shadow. We can also see some shadows on the edge of our trees here. But here again is that feature that we were looking at earlier. And there is no shadow for this feature, none whatsoever, which tells us that this is actually flat on the ground. So what could be flat on the ground and have this shape with a connecting roadway to it? Well, my mind, knowing our community, is that it could either be some sort of a play structure or a playground, but also knowing that this huge structure over here is our hospital gives us that final piece of information we need to figure out that this is actually the helicopter landing pad for the emergency rescue. Let's practice a little bit more. Now I've got some Google Earth imagery from the middle of Arizona, and if we were here tasked with identifying what surface features we have, if we were just using a digital computer to do that, you might see something here that to us we can clearly say, well, based on that shape and pattern and the color, that's got to be a river, right? So we can do that with our brains, and the computer could do that as well. But it likely would also see this one over here and say, oh yeah, well that's the same color and it has sort of the same shape, so that must be another river. But hopefully with our human brain we can say, well, no, I'm not really sure. That looks kind of funky, especially if you put it in context with the rest of its landscape. I've never seen a river that just goes around in a circle like this, well, except for the lazy river maybe at your local water park. So if we zoom in a little bit closer, we can see that actually what that darker band is not water, but is actually a change in elevation, and we're seeing shadow around this raised plateau in the desert. So we'd have to be thinking about other ways or other elements of interpretation that we could use to train our imagery to be able to classify that accurately. There are some other features in here, though, that are pretty interesting as well. This nice straight line, whenever we see something very uniform with crisp edges like that, we can assume that that's man-made. And indeed, if we zoom in, we can see a series of roads in here. Also interesting are these other arroyos, so we can actually tell something about the topography and the hydrology of this region just by using differences in color. So the elements I'm using to determine that is that we have these sort of lighter regions with less vegetation where the water flows regularly and some of that surface sand is washed away. But then also the pattern of this tells me this is likely not man-made, but is a natural feature. So even without knowing it, we're often using these various elements of interpretation. And the trick for us in our modern day is to think about how to capture those characteristics and train a computer to distinguish objects for us. Consider this your fast and dirty introduction to photo interpretation. Really, nothing can beat the human brain, and so these techniques are really valuable. Pretty much the only time that a computer could beat the human brain is if there are multiple bands, so lots of different wavelengths, and the human eye can only process really 3 bands at a time for a color image. We can't go into multi-dimensional space with our eyeballs. So, really for the most part, the human brain can do a good job, but the problem is there's just too much land to cover, too many images to look at, and not enough people or time, and plus sometimes some people see things differently than other people, so there's not a lot of consistency with photo interpretation, and in fact repeatability can be a problem. So that was part of what pushed us towards digital image processing, and I'm going to close out this video now just because it's getting long and really large, and we'll start up another video to explore digital image processing a little bit more.